Welcome back to the GT350 Garage. My name's Walter, and in this video, we are going to measure bearing clearances. But before we can do that, I got to show you how to calibrate a mic. And then I got to show you how to set up a dial bore gauge. And I'm going to show you how to use those miserable little T gauges that I hate so much. But while I'm there, I'm also going to show you a trick that I use for taking the rods apart. And this will help you if you don't have a rod vise or soft jaws for your vise. It just simplifies the process and makes it so that you can get the rod bolts loose, especially when you get into the Eagle rods where the rod bolt torque is over 60 foot-pounds. They can be real challenging to get the bolts to break loose if you don't have a way of holding the rod. So there's some little tricks I'm going to show you on that. I'm also going to show you a real common mistake when it comes to installing rod bearings and how to correct it, how to check for it, and then how to correct it. So these are things that are in this video that are beyond the normal just measuring. You're going to learn how to use the tools, you're going to learn how to check things, and you're going to learn how to disassemble things in a slightly different manner. So I'm going to show you all that stuff, and then we're going to get going. Now, this is a long video. I'm going to tell you that right now. And if you are looking for how to do this in 5 minutes or less, this isn't the video for you. Okay? I'm gonna shoot you straight. Okay? When you're talking about making more than 480 horsepower out of an engine that's less than 300 cubic inches, that's a pretty high performance build. When you're talking about building an engine that's going to run over 7,000 RPM, that's a pretty high performance build. When you're talking about building an engine that's over 12-to-1 compression, that's a fairly high performance build. And building the engine so that it'll run on pump gas, that's a precision build. Okay? So we have to focus on precision, and we have to make sure that we're doing all of these things with accuracy and taking our time. If you don't have the time, you shouldn't be building an engine like this, at least in your own garage. Pay somebody to do it for you, okay? Pay somebody that does it all the time so that you don't end up with a big old failure and a heap of expensive parts under your hood. If you feel like you need the 5-minute solution, go buy some plastic gauge, slap it together, cross your fingers, hope for the best. And I don't know any other way of saying it than that. You know, that's the problem with this industry right now is we have too many people want instant gratification. And this is not an instant gratification process. This is slow. This is deliberate. This is precise. This is, I want it to be very, very good. And in order for that to happen, we got to take our time. We got to have the right attitude. Okay? So if your attitude is, I want it done in 5 minutes, then bye. See ya. This isn't for you. Okay? If you like what you see in this video, give it a thumbs up. Appreciate it. It helps populate the video into the algorithm, and then more people get to see it. And the way I'm doing this, I think a lot of people can actually learn a lot from this. And it doesn't matter whether you're building a small block Ford, a Chevy, a Mopar, an AMC, hell, Honda, Toyota. It doesn't matter. If you're building an engine, the use of the tools is the same. Okay? So in that particular respect, you know, if you get something out of this, definitely give it the thumbs up so that other people can get something out of it too. And if you have questions, leave a comment. I read the comments, I answer the comments, and I'm happy to help with the basics. If you need more than you feel like a comment is going to get you, then shoot me an email. The email's theGT350garage@gmail.com. Easy. So let's get started with this video, and let's take some measurements and use some calibrated tools. All right, I need to give you a quick lesson in how to use a micrometer and a dial bore gauge, and it all starts with calibration. So take your mic. You need the calibration tool. This is a 2 to 3 inch mic. This is a 2-inch calibration tool. We're going to put the calibration tool in the mic, and we're going to tighten it down until the ratchet clicks. Now at that point, we're going to look really carefully, and we're going to see that we are way off. On the back side of the mic, there's a little hole, and we have this tool, kind of like what you'd use to adjust coilovers. And you're going to basically just bring this guy around. Let's see if we can focus on this here. Bring this around until it reads exactly 2. So now we're at exactly 2 inches. We can drop our calibration tool out, and we can proceed with setting up and calibrating our dial bore gauge. Now, the reason it's important that we do this is we're going to be using this to measure the journals. So now we've calibrated it to 2 inch, and every measurement we take on our journals is going to be relevant to every measurement we take of the bearings, because the tool measuring the bearings and the tool measuring the journals are all calibrated off of this same piece. So that's the important part that you guys need to understand here. Put your calibration tools away so that you have them the next time you need them. Now take your mic and open your mic up. We're going to roll this guy back. That's 205 to 100 to 125 to 150, 175 to 200. Now our crankshaft on a small block Ford is 2.25. So 25, 35, 45. This is 2.250. When you lock this, quite often this is going to want to move. This is the one time I'll tell you to hold it in place, and you can see it still tried to move. Get it about there and lock it in. That's it. Set it up. Make sure you hold this as much as possible by the plastic, not by the metal. The temperature in your hand will cause the metal to expand, and it'll change the distance and screw with your calibration. Okay. Dial bore gauge. The dial is a dial test indicator, and these guys ship in a protective case. I keep mine stored in the protective case because it is a protective case, and it makes it so that this dial indicator won't get messed up. Now, I've loosened the screws already. You're going to take the clamp off, set it aside. You have to take this out of the plastic case, set the plastic case aside. Now, that goes into the actual dial bore gauge, and as you put it in, you'll see that it moves the needle. And that's fine for right now. Just put it in there partway and snug the clamp down. All right, we have all these pins. They range from 2 inch to 4 inch for this particular anvil, and then there's a set of anvils for measuring 1.4 to 2 inch. So this is for our small bores, and we're set up for bigger bores. What we have here is the 2.2, and then this ring is a 50 thousandths ring. So we put the 50 thousandths ring on it, and now it's 2.250. So we're going to put that on there, and we're going to snug it down. It doesn't have to be crazy tight. Okay. Now, this is where it gets tricky, and this is what I've got to show you. If we were to set this up, and I'm going to loosen this up, and we back this off until it reads 0. We'll get it really close. Actually, we'll just set it right there, straight up and down. We'll get it really close. We'll loosen up the ring. We'll dial that in, and we're going to set it to exactly 0. Okay. You would say, okay, this is set up for 2.250, right? Watch what happens when we measure this on the mic. Let me move the camera really quick. Oh, would you look at that? We're 25 thousandths off. Go figure, right? So there's automatically, when you're measuring this, the contact point is already 25 thousandths out. So to get this right, you have to adjust this measurement. And to do that, we're going to put this in here like so. We're going to loosen up this nut. You see the gauge falls. Snug it up just enough that it... There we go. And what we're going to do is we're going to weasel this guy down in here until it's about spot on. That's pretty close. So now any fine tuning we do is going to be with the outer ring. So we're looking for the biggest measurement. Or in this case, the most clockwise movement of the dial gauge. There we go. Now, here's where this gets funky. Let's say we're trying to measure 2.240. So we're going to take 10 thousandths out of our mic. So that would get us to right here. Put the brake back on. And this is where I have so now we are 10 thousandths undersize. And let me see if I can move the camera again. You have to make sure that you're straight all the way around. And there we are. We're at 10 thousandths. Okay. So that's one way of setting this up. Another way to set this up, and this is what I prefer, is I know that I'm going to be at 2.240 as my measurement because that's what my crank is ground to, right? Take this dial and move it. Move it back to 0. Now we're calibrating it to 2.240. right there. Lock it in. And now we're calibrated to 2.240. So when we measure our bearings, if we're right on, we're at 2.240. If we're here, we're bigger. If we're here, we're smaller, if that makes sense. So basically, anytime the black number goes positive, we're smaller by that amount. Anytime the red number, which is kind of hard to see, but there's a red number. The red number means we're bigger, and the black numbers mean we're smaller. All right, so that's how we're going to calibrate this gauge, and that's how we're going to measure all of our bearings. All right, let's talk about tools. If we're going to measure clearances in an engine, we're going to need some tools. And for this particular video, the tools we're specifically going to be using are going to measure outside diameter and inside diameter. So what I have here is a selection of tools for measuring outside diameter and inside diameter. I have some really cheap telescoping gauges. I have some really good telescoping gauges. I have a dial bore gauge, and I have micrometers. So here's the key with this. I hate telescoping gauges. They're really, really difficult to use accurately. The best way I can explain that is demonstrating how they work on a connecting rod. And for that, I guess we'll pull a smaller one out. And we're just going to measure the wrist pin, because we know that the wrist pin on a small block Ford is basically 9/12. We can do a quick with a caliper. First, let's check to make sure that we're calibrated. And we're off just a hair. Oh, now we're off a whole lot. So we're going to calibrate the mic. There we go. Spot on, that's 0. So we verify, it comes back to 0. So wheel this guy out, and we should be at 0.912. So let's see. 6, 7, 8. There's 9. All right, so we're going to go to all right, and we come in at 911 and a half. Okay, so now we're going to measure with our snap gauge or our T gauge, whatever you want to call it, same thing. And we're going to open that up. And the key with this is you have to make sure that you are running your T gauge in the exact same line as the bore you're measuring. If you don't, you're not going to get an accurate measurement. So that's about as perfect as I can get it. And now we have to measure the T gauge with the caliper. So we got to open this back up. So that's 925. And this is why I hate these. They're such a pain in the ass to use. You have to find somewhere that you can hold this T gauge and then accurately measure it, and we come up at just a hair over 912. So our clearance is pretty tight for this wrist pin, and you can feel that it's snug. So a half a thousandth, basically a half a thousandth of radial clearance which is 1/4 thousandth all the way around, is all we have for clearance on here. So we just measured the inside diameter, we measured the pin. Put that back. All right, I'm going to show you guys a trick that I use to loosen up the rod bolts on these connecting rods. And this is if you don't have a rod vise. Not everybody has a vise, and not everybody has a rod vise. Get a good sturdy handle. This is a fiberglass composite handle, 4-pound sledgehammer, and works just fine. Get the correct ratchet and socket for the bolt or the nut that you're trying to take loose. And what you can do is just simply use the handle of a hammer to break these guys loose. So in this particular case, these bolts are torqued to 63 foot-pounds. So we've got some effort to get these loose. Okay. And we'll do the entire set like this. And the reason I use a hammer with a rubber handle is it won't mar the rod. And I've done them like this for 25 years, and it just works absolutely fine. The further you can keep the bolt towards the end of the rod, the more leverage the hammer gives you against the rod. If you use a good size ratchet, this is a 1/2-inch drive ratchet, it just makes everything all that much easier. And I'd already done the first two, and I thought I should really show this process. Actually, I'd already done the first three. So this is the process. If you are wondering how to get the rod bolts loose, don't use an impact. Don't clamp the rod in a regular bench vise and fight with it. And this one's already got the bearings in it, so I don't need to take this one apart. The next thing is, once you have all your bolts loosened up, you have to split the caps on these rods. And splitting the caps on the rods can be kind of a daunting task because these have a dowel pin that holds them in alignment. So we have our rods here, and they're out of the way. Take your bolts out, set them down. Rubber mallet. And I realize a lot of guys will tell you, just get a rod splitter. Well, if you don't want to spending a bunch of money on tools, because you're not going to be doing this professionally, just use a rubber mallet, take your time, and pull your caps off. Then you can put your bearings in. Make sure you pay attention when you're putting these back together. There's no chamfer on one side of the rod, and there's a pretty healthy chamfer on the other side of the rod. That chamfer is there for the radius on the connecting rod journal. It is possible to put the cap on backwards. It's pretty obvious that it's on backwards. Well, what will happen is you won't see this when you assemble it because all you're seeing is that. And then you'll go to turn the engine and the engine won't turn. So that's an issue. The other thing you need to know if you're new to building engines The notch for the connecting rod bearing, which doesn't prevent the bearing from spinning. Those little tangs on there are only to align the bearing side to side. They don't prevent it from spinning. The notch always goes towards the camshaft. Okay, I want to show you guys a mistake a lot of guys make when they're putting in rod bearings, and it's a really easy mistake to make. If you look, that bearing's not lined up. And you can see on either side that the bearing is not square. So what's going to happen is that's going to change our clearance. And if we want a correct clearance, we need to make sure our bearing is straight. So when you're assembling your rods, make sure that you line up the bearing so that this edge is straight on both sides, and so that when you look at the side opposite the notches, you have the same amount of clearance to the rod as the side with the notches. So what we're looking for ideally is this bearing to be in the bore, square to the bore. If we have the bearing in here square, we'll have an accurate rod bearing clearance, and that will just ensure that whatever we measure here is accurate this way, and this way on all of our rod bearings. So I've already done this on the other 8 rods. I'm going to torque this one, and then we're going to measure the rods. Okay, so I've got my connecting rods set out here, and I showed you how to line the bearings up so that we make sure the bearing is straight, because if our bearing's not straight in the bore, it's going to twist and it's going to throw off our measurements. So we want to make sure our bearings are straight, and then we're good to measure. Now you can see if you look closely, I've already measured these, and I know where I'm at as far as my measurements are concerned, but this is what we're going to be doing. We've calibrated the mic back to 2.113. Here, let's double check. Okay, 2.113 gives us exactly 0 on our dial bore gauge. So now what we're going to do, and I've got my rods numbered 1 through 8. Don't worry about that for right now, because they're not actually numbered to any particular cylinder. This is just for record keeping purposes. So what we're going to do is we're going to measure the rod, and we're 2/1000ths big, so we're at 2.115. Okay, turn it, measure it again, and still 2/1000ths. Turn it, measure it again, still 2/1000ths. So at that point, on the rod itself, I write 2.115 with a 0, because it's not a half, it's a whole. Do the same thing. Spot on. Right where we want to be. And I can remember that number because it's the same. So every one of these came out exactly the same at 2.1150. All right, so we need to measure the main bearings now. All of our main caps are torqued to 70 foot-pounds. Let's get going here. Okay, so that would be 240 with a 1. 240 with a 1. We're just going to check and make sure it's round. This block was line honed. 240 with a 1. 240 with a 1. .240 with a 1. And again, 240 with a 1. So, I'm not going to measure every bearing for roundness because this block has been line bored. But I just showed you the process. We're going to measure vertical, and then we're going to measure this way, and then we're going to measure this way. And then we're going to measure the front half of the bearing and the back half of the bearing. And the reason for that is we want to check for taper front to back, and we want to check for out of round around the bearing. If your block has not been line honed or line bored, I would strongly recommend that you check every bearing in 6 places. Okay? I'm going to check all of these in 2 places. So, the other thing is, when you're doing this job, have a Sharpie handy, just like we did for the rods. 2.241 with a 0. Write it down, and then you're going to need to break the bolts loose, and you're going to need to remove the cap. I saw a video recently where a guy was freaking out about measuring the bearing diameters with rod cap or main caps removed. This main cap has no bearing on this main cap. Pun intended. This main cap does not distort the block when it's torqued into place and affect this main or this main or this main or this main. It's not going to move. So take your caps out of the way and simplify your life so that you can measure this stuff quickly and easily. Also, if you pull the rod bolts up, you can use them as leverage to pop your caps off. Make sure you drop the bolts. Gives you good exercise having to bend over to pick them up. Okay, at this point, I've actually measured this multiple times, and I have checked every one of these bores for roundness. But when I was filming this for the umpteenth time so that I could show this process as carefully as possible, I wanted to show that there's more than one way to do this. So with that, please be sure to measure things as accurately as you would want to measure them. In this particular case, I know that every one of these bores is round. Now, when I got to the thrust bearing on this engine, these are 4125 MA 10 under bearings from Federal Mogul. They have started including a bimetal upper bearing and a trimetal lower bearing in these sets, so they look a little funky. The one thing I will say is the vertical dimension was correct and measured the same as the rest of the bearings. But when I measured 60 degrees either side of vertical, I noticed that the clearance got bigger. So I took some additional measurements, and what I found was a little more side clearance on the bearing on the side of the crankshaft, which will just mean we get a little more oil into the thrust surfaces. Another thing I want to bring to your attention while we're at this point, make sure you put the thrust bearing on the number 3 main. I've seen several cases recently where guys have got the thrust bearing on number 5 next to the rear main seal, and that simply will not work on a small block Ford. You're going to have over 1/8 of an inch of thrust because there's no thrust surfaces on the crankshaft at that point. And when you put the main cap on, it's going to lock up the engine. So make sure you know where your thrust bearing goes and install it in the correct location. Okay, it's time to measure the crankshaft. So this is a pretty basic process. We're just going to be using a micrometer. We're going to measure all of our mains. We've got 5 of them, and then all of our rods. And when we measure these, we're going to measure front and back so that we can check for taper, and we're going to measure in 3 places. We have to make sure we don't hit the oil hole. So here we have an oil hole, an oil hole, and we have an oil hole. So this oil hole goes to this side of the journal. There's an oil hole here that goes to this side of the journal. We're going to measure our mains first, then we'll measure our rods. I'll show you how we do it and how I line up the crankshaft so that I can get these measurements. Now, part of this process is I take a piece of paper and I have my block measurements, my crank measurements, my clearance, my rod measurements, my crank measurements, my clearance. But you'll notice if we look closely here, I put 1 and 5, 2 and 6, 3 and 7, 4 and 8. Those are the pairs. I can go ahead and transfer over my block measurements now, and those are 2.2410, 2.2410. Oop. This one was 05. 2.2410 and 2.2410. So we're going to subtract the diameter of the crank from that. And in each case, that's going to tell us what our oil clearances are. Now with the rods, I'm not going to put the rods on here yet because I want to measure the crankshaft first. Once I have the crankshaft measured, then I can go back. Now all of these rods are the same, fortunately. But if I had any rods that were different, I could go back and I could match my rod to my crank. And that way I can pair my clearances. So this is something that you may want to do when you're building an engine, is actually verify the rod dimension to the crank dimension so that you can fine tune your clearances. It just works better that way. So let's get started on this. It doesn't take long. So let's see, 39, 38 and a half. 38 and a half. 38 and a half. 38 and a half. 38 and a quarter. 38. What's going on here? Let's go back to our original measurement. 38 and a half. $38 and a quarter. So we have about 1/4 of a thousandth low in our journal right here. Not a big deal. 1/4 of a thousandth, I'm not worried about. It's when you measure one of these crankshafts and the sucker comes in at thousandth and a half out of round, and your bearing clearances aren't right. 38 and a half. All right, excuse the edit here because this footage was filmed in high speed so that it takes the time frame down on the video. Basically, we're just going through the rest of the main bearing clearances here, measuring everything carefully, and then documenting everything. Same process we used on number 1 main, just done at a different time so that I could speed up the video and make this a little bit shorter. Otherwise, this is about a 6-minute process. All right. So 410 minus 385. It's 10, it's 25. 0.0025. 410 minus 385. 405 minus 380. 0.0025. 410 minus 38 with a 2. 0.0028, and 410 minus 385 again, 0.0025. So we have 2.5 thousandths on our mains with one that's just a touch big, and I'm absolutely fine with that. So now it's time to measure the rods. Roll the crankshaft so the oil holes are facing you. So your oil holes are here. Now we can measure here, here, and here. And we don't have to worry about the oil holes being in our way. So we're going to take our mic in to approximately where we need to be. Start at the front. And we're at 112.5. Let's make sure this sucker's round. 2.5. 2.5. So 2.1125. Now, notice that I took the measurement for this half of the journal and I wrote it down. Now that's number 1 rod goes here. Number 5 rod goes here. So 2.5. 2.5. 2.5. So it's the same. 2.1125. Now again, roll your crankshaft so your oil holes are facing you. You're going to repeat this every time you do a measurement on the crankshaft. One more edit to make 6 to 8 minutes, a whopping 25 seconds. Just make sure you turn the crankshaft and keep those oil holes facing towards you. It'll make your measurement process go a whole lot easier. Measure everything and align it to the connecting rod that you're going to be putting with the clearances off of that position of the crankshaft. Now, we know all of our rods measure the same. 2.1150. So we're going to write all that down in our rod column. And And 50 minus 25 is 25. So our clearance, if we look at this, 50 minus 25, you can get rid of all the numbers at the beginning that are the same. 0.0025. And that's going to carry the entire way down this column. So we have 2.5 thousandths on our rods, 2.5 thousandths on our mains. And that is our clearance. All right, I know that took a while, and I appreciate if you stuck around for the video this long. Thank you. I hope you learned something. I hope that it helps you understand the process of measuring your bearing clearances. Now, what I can tell you from the clearances that I have is with 2.5 thousandths clearance, I'm going to be running a high volume oil pump. And there's a whole crowd of people that are like, high volume oil pumps are a waste of time. Okay, well, there's a reason I run a high volume oil pump. I'm running fairly big clearances. 2.5 thousandths is on the upper end of the clearance scale. And by the time the engine wears in, it's going to be closer to 3 thousandths on the mains, probably 2.6.5, 2.7. So, you know, we're getting close to 3 thousandths, right? We're going to move a lot of oil through this engine. Oil cools parts, period, right? So if I run a high volume pump, I can move a lot of oil. This is the key. I don't want pressure. I want volume. So in order to not have excessive pressure, I'm going to run a thinner oil. With these clearances in a high volume pump, I'm going to be running more than likely 530 in this engine. Okay. And a stock small block Ford was designed to run 1030. Now, depending on what I see when the engine gets up to operating temperature and I'm using the engine in the real world, depending on what I see for my oil pressures, I can change the performance of the oil by changing the weight of the oil. In other words, if my hot oil pressure is not where I want it to be, let's say I've got 55 pounds at 7,200 RPM and I want 65. And I'm running 5W30. Well, that's an easy fix. Believe it or not, that's an easy fix. I just go to a 5W40. And let's say I have 90 pounds of oil pressure when I start the engine cold. Well, then I go from a 5 down to a 0. Okay? That's the way it works. So I will play around with the oil once the engine's in the car, but my starting is going to be 5W30. And I expect good results with 5W30 in this particular engine. It should work incredibly well, and I should have good oil pressure performance across the range. So that's the importance of all of this, is now I can predict where I want to be with respect to how much oil I'm pumping through the engine. And knowing where I'm going to be by knowing what my clearances are gives me the confidence to be able to pick the oil that I want to run and use it with good success. The engine will get broken in on a standard non-synthetic oil, and probably by the time it has 1,000 miles on it, it'll be on synthetic. Okay. This is a roller engine. I'm not worried about camshaft break-in. And the way the cylinders are machined and the rings I've selected, this engine will be broken in within the first couple hundred miles. And that's perfect. So, you know, realistically, I could put a synthetic oil in it as early as 500 miles. So it'll just depend on what I see as far as oil pressure in the first couple hundred miles. And then we'll go from there. So anyways, all that said, I hope you enjoyed the video. I thank you for watching. I thank you for sticking around this long, and I'll see you in the next one.